but it's not. It's deceptive. It's an innocent-looking problem. All right, now we have to compute. Let's see. So it would be del m del y. That's going to be, what's that going to be? 4y? 4y, so 4y, okay. And then we have to compute del n del x. Is that 2y? No. So this is what? So it's not exact. So now we have to try to make it exact. So we just have to subtract. So let's just take my minus nx and see what happens. I don't know if it's going to work. I don't want to think about it. I'm just going to write it down. If it doesn't work, we give up. I don't want to like think about it in my head. It's too late to do that. So my minus nx, I'm just going to write it down without thinking. Mindless. Worst case scenario, we just wasted a minute and a half of our lives and we do it the other way. Okay, so my was 4y. Nx was 2y. And then we divide by n. What was n in this case? 2xy. Right, it's up here. Right? You can try to do it in your head. I recommend against it, right? When you try to use this stuff in your head, it's like, oh. It's not at this hour. So this is 2y. Yeah, not this late. No. 2xy. Anything cancel? The 2's and the y's. Oh, and this is 1 over x. Oh, it's an x here, and this is a pure function of x, right? What if this didn't work? Then we just flip them and divide by n, right? We try the other way. And if that doesn't work, then we just give up. Yeah, class over. Yeah, no, we would just give up, right? So that's not. We'll try something else. My minus nx over n, and it's a pure function of x. So if we had gotten like 1 over xy, then you would have tried nx minus my and divided by n. Right, you would have tried something else. Anything hazy up to here? Right, so now we have to compute our integrating factor. So mu of x is equal to e to the integral of 1 over x with respect to x, right? Because this is this creature, it goes over here. So this is 1 over x dx. Oh, we've done this 1,000 times, right? What is the antiderivative? It sounds complicated. Yes, e to the ln, absolute value of x, plus a c, which doesn't matter. This is the absolute value of x, but we can say this is equal to x if x is positive, right? Every single mundane detail. Well, not mundane. Oh, yeah, not mundane. Mundane means ordinary. Yeah, mundane. Okay. I looked it up once. Okay, so it was in a movie. So I Googled it. All right. So now this is our integrating factor. So what do we do with the integrating factor? We multiply it by what? By the whole thing. So we're going to take the whole equation and multiply it by the integrating factor. So take the whole thing. So multiply this by x, multiply this by x, multiply this by x, multiply this by x. The entire thing, right? So let's see. It's going to be parentheses 2x y squared plus 9x squared. Yeah. Good, very good. Dx, not losing any more points. Plus, no way, not going to happen. Ever again, never in the course. Plus 2x squared, solid, y dy. And then this is just going to be 0, because x times 0 is 0, right? So this is just 0. Okay, and then what do we do? Well, we start over. Yeah.
What were we doing there?
We're multiplying everything, Ryan, by mu of x. Okay, no, ask. Yeah.
When you did the condition where you dropped the value, would it be x greater or equal to 0?
It doesn't matter. It's up to you. Mm-hmm. I did greater than. Actually, it does matter. It can't be equal to 0 because you have 1 over x.
Exactly.
But technically, in the definition of absolute value, you're allowed to have a qualitative. Right, because the definition of absolute value, really quick, hits the rail, but it's such a good question. It's a good question. This is the definition of absolute value. You can put that part there. You can put it here. You can put it here. And if you really want to be abusive, you can put it in both places. No, it's still okay. You can put it in the top and the bottom, and it's okay. It's legal. But yeah. Okay. All right. So now we start over. This is our new big M. And this is, I mean, we could call it M tilde, but let's not. Right?
Not daytime.
To give it, I mean, so we're being really abusive here, right? So this is our new big M and our new big N. And we have to check to see if it's exact, right? Because what if we did it wrong? So let's check. So del N, this marker's really bad, del Y is equal to, is that going to be 4xy? 4xy. 4xy. And then this is, I'm sorry, del N, del X. This is going to be, is that 4xy again? 4xy? Oh, we have to check again. Yeah, what if we did it wrong, right? What if, you know? And then so in this case, is what do we say? It's what? It's exact. It's exact. So fine. Now we can start the problem. So it's so these are tough. Right? These are tougher than, well, not tough, but longer than the other ones. Okay. Any questions up to here? Everyone okay with what we did here with this idea? Anyone not get it? All right, let's finish it and we'll go over it again then, just from the beginning. All right. So this means, so there exists some unknown function f, yeah, whose total differential is the left-hand side, whose total differential is this differential equation. In particular, this is del f del x, and this is del f del y. So del f del x is this piece. So del f del x, good stuff. I love the dels. So 2x y squared plus 9x squared. And then this would be del f del y. So del f del y would be that piece over there. So this would be del f del y. This is 2x squared y. Yeah, so I was thinking about something else. Integrate. Which one do you want to integrate? Yeah, let's be different. Yeah, let's live a little. Yeah, this will do it twice here, right? It won't work. So it's not about living; it's about just taking the easy route, right? Easy is always better, right? So let's take f of x y, and we're integrating with respect to y. So there's a 1 here, so we're going to add 1 and divide by 2. What's going to happen with 2? It's going to cancel out. So we get x squared y squared plus little g of x. It's a deduction. I'm kidding.